u cos beta into 2u sin beta by g cos alpha minus half g sin alpha into t square, that is 4u square sin square beta by g square cos square alpha. So we can cancel out 1g here. Now making the denominator of these two terms common, we'll get 2g cos square alpha, and in the numerator we'll have to multiply this numerator with 2 into cos alpha, so we'll get 2 cos alpha into u cos beta into 2u sin beta minus 4u square sin alpha into sin beta, which is equal to, again we can take 4 sin beta common in the numerator, so in fact we can take 4u sin beta common, 4u square sin beta common, 4 sin beta into u square. So what is left here is cos alpha into cos beta, and here it is sin alpha into sin beta, this is sin square beta, by 2g cos square alpha. So this is nothing but cos alpha plus beta, and we can make this cancellation. So finally we have the range of the projectile as 2u square sin beta into cos alpha plus beta by g cos square alpha. So this is the range of the projectile on an inclined plane. Now let's see what is the maximum range of the projectile along the inclined plane. For any given inclination angle alpha, the range will be maximum when dr by d beta is equal to 0. So let's calculate this maximum range. So we already have range r is equal to 2u square by g cos square alpha into sin beta into cos alpha plus beta. So now let's find out what is dr by d beta. This will be 2u square by g cos square alpha. Derivative of sin beta is cos beta. The derivative of cos alpha plus beta is minus sin alpha plus beta. So this term is nothing but cos beta plus alpha plus beta so we have dr by d beta as 2u square by g cos square alpha into cos alpha plus 2 beta. So for maximum range, dr by d beta should be equal to 0, that is cos alpha plus 2 beta should be equal to 0, or alpha plus 2 beta should be equal to 90 degree. So this is the condition for the range to be maximum. So from here we can get the value of angle beta. This will be 90 degree minus alpha by 2. Now the value of beta is 90 minus alpha by 2, which implies that the condition for maximum range along the plane is that the projectile should be projected along the angular bisector of the angle between vertical and inclined plane. So let's see this in the figure. Now the angle between vertical plane and inclined plane is 90 minus alpha, because this is our inclined plane which is at an angle alpha to the horizontal plane, and the angle between vertical plane, this is our vertical plane, and this is our inclined plane. So this angle is nothing but 90 minus alpha, and the value of beta is 90 minus alpha by 2. So the angle of projection should be the angular bisector of the angle made between vertical plane and inclined plane. Now let's find out the value of maximum range, that is R max. This value comes out to be u square by g into 1 plus sine alpha. Now let's derive this expression. So the value of R is 2u square by g cos square alpha into sine beta into cos alpha plus beta. Now beta is nothing but 90 minus alpha by 2 for maximum range, so R max would be 2u square by g into cos square alpha. Now we can write cos square alpha as 1 minus sine square alpha, and inside the bracket we'll put the value of beta, that is sine 90 minus alpha by 2, and here it will be cos 90 plus alpha by 2. So we have u square by g into 1 minus sine square alpha, which we can write as 1 minus sine alpha into 1 plus sine alpha, and here we can write it as 2 into sine 90 minus alpha by 2 into cos 90 plus alpha by 2. Now 2 sine A, suppose this angle is A and this angle is B, so 2 sine A into cos B can be written as sine A plus B plus sine A minus B. This is a trigonometrical identity. So if we apply this identity here, we'll get u square by g into 1 minus sine alpha into 1 plus sine alpha. Now sine A plus B would be sine 90 minus alpha plus 90 plus alpha by 2, plus sine A minus B would be sine 90 minus alpha minus 90 minus alpha by 2. So alpha gets cancelled out, and here 90 gets cancelled out. So finally we have u square by g into 1 minus sine alpha into 1 plus sine alpha into, this is sine 90 degree, which is 1, and this is sine minus alpha, which is minus sine alpha. So we can cancel out 1 minus sine alpha. So finally we are left with